All right, geometry. Um, Good morning, good afternoon, whatever time of day you're watching this video. Just wanted to kind of get you guys caught up to speed on why I'm not here today. I think I probably told you yesterday that the entire district's getting together to talk over how we are doing meeting the new criteria that the state has come to as far as the Common Core and the new park assessment. And so while I'm probably in the building, we are meeting together and discussing that. And so I really liked how things went last week, or actually 2 weeks ago, a week and a half ago now, when I was at the other math conference. And so I'm going to kind of run today the same way, where I'm going to give you guys some notes, and I'd like you guys to watch the video and then kind of come back and make sure that we know how to do the work that I've presented. And so before we get started, I know how much you guys enjoyed the polygon joke that I told you. I couldn't think of another joke that would really respond to anything that funny, but I do remember a YouTube video that kind of showed why you need to know math, a little Abbott and Costello act that they used to do. And I want to share that with you guys. And so I'm going to have you guys watch this video now, and from there, then I'll go ahead and do my spiel. So here's the video that I think is pretty funny, and I'll let you guys watch it as an introduction.
Mr. Landlord.
Yeah?
What are you smoking, an army blanket?
Never mind about that. You owe me room rent.
All right, here's $28.
$28, fine. Just a minute. You owe me 13 weeks. That's $7 a week, and that happens to be a lot more than $28.
Well, that comes to $28.
Did you go to school?
Yes, sir.
Do you mean to say that you can prove that 7 times 13 is 28?
Well, it's got to be. Certainly it is, because Mr. Rabbit and I, that's $28. That's what you get.
If you can prove it, I'll tell you what I'll do. I will give you the room rent for nothing.
You will?
But if you don't prove it, you owe me double the back rent. Is it a deal?
That's a deal.
Okay.
Do you happen to have any Crayola on there?
Crayola?
Never mind. I got it.
Oh, you have?
I got the Crayola. The 7 into 28 is going to come out 13.
That's your way.
That's my way. And it's got to come out right. Now, first, I put down the 7.
Right.
Now, I'm going to divide the 7 into 28.
Yeah.
I put a 28 there.
Okay.
Isn't that cute? Now, here we go. 7 into 2. 7 will not go into 2.
It will not.
That's a very big 7 to push into that little bit of 2.
There it is.
We ain't going to hurt that little 2, are we?
Of course you won't.
Now, we take the 2. Open your hand.
Yes.
And I put that 2 right there for safekeeping. But don't drop it and don't lose it. Now, 7 into 8.
Once.
I put the 1 over here, 1 over there. Now, we're going to carry the 7 because it's very big and it's getting heavy on my shoulders, and I'm going to drop the 7 under there. Now, 7 from 8
Is what?
is 1. I put the 1 down there.
Mm-hmm.
Now it comes. Would you mind opening up your palm of your hand, please? I would like to use that 2. Open it up. Give me that 2. You had it long enough. I'm going to put that 2 right there. Now, 7 into 21?
3 times.
That's right. 7 into 28? 13.
Wait a minute. You have to prove this even better than that. You can prove it very easily by multiplication.
You mean you want me to multiply it?
No, not multiply. Multiply. Multiply.
All right. Multiply it.
7 times 13 is 28. Go ahead.
Now, first, we've got to put down a 13, right?
Right.
There's a 13.
Times 7.
Times 7.
Right.
7 weeks times 13, right? 7 times 3?
21.
21. 7 times 1?
7.
7. 7 and 1?
8.
And 2 to carry. 28.
Now, wait a minute. I'm still not convinced. There's one sure way of proving this. One sure way, and that's by addition.
You want me to addition it up?
I want you to put 13 7 times on that wall and then draw a line and add them up.
You want me to put down 13 7 times?
That's right.
That's got to come out right. There's 1,
1,
2,
2,
3,
3,
4,
4,
5,
5,
6,
6.
7.
Wait a minute. What's the idea of spreading them out like that?
Well, it looks like a flock of seagulls going to hit the electric poles. Now we're going to add them up, right?
All right, go ahead.
Here we go. 3, 6,
Wait a
9.
minute. Let me do the adding this time.
Come out right.
Well,
That's 3, that's 6, and 9.
Just a minute. I will do the adding. Then there'll be no mistake.
Yeah?
21.
22, 23, 24, 25, 26, 27, 28.
So like I said there, folks, I hope that you enjoyed that little video right there. I saw that a couple years ago and thought that was pretty funny and wanted to share that with you. Now, obviously, today's lesson is not going to take very long, and I may have explained that yesterday, and so that's why I took that time to show that video. So, get this pin back on here. All right, now, here's what I want to do. We have talked earlier this year that the sides of a triangle influence the angles opposite. And so if I were to go ahead and draw a triangle on the paper here, I'll just label it ABC. And again, I'm not actually drawing this to accurate measurements, but I just want you to see something that we're about to work on. If I were to assign some values here, let's say that this is the length of 9. Let's say that this were a length of 13 and this were a length of 12. Okay? Now from there, I want you to think about which angle do you think is going to be the smallest, which angle is going to be the largest, and which angle is going to be somewhat in between. So if we go back to the concept I just talked about, the side opposite influence the angle. I choose the smallest side. The angle opposite needs to be the smallest angle, okay? And if I were to go ahead and take this angle, and let's say that I were to move this side out like that, what would happen to the length here, this length right here? Well, obviously it would increase. Well, what would happen to this angle right here? Well, obviously it would increase as well. So the angles of a triangle are influenced by the sides opposite. If I want to find the next smallest side, I choose the next smallest angle, or smallest side. Choose the next smallest side, and the angle opposite is going to be the next smallest angle. And so the largest angle within this figure is opposite the longest side. And so from smallest to largest, as far as the angles are concerned, we're going to go with angle C, then angle A, and then angle B. Okay? All right, now, keeping that in mind, I'm going to show you a couple of examples here, and I'd like you to work through those examples for me. So starting with, let's say, this triangle right here. Take a moment. I want you to identify the smallest angle, then the next smallest angle, and then the largest angle. Okay, ignore the directions there at the top. Okay. Now, I hope that you chose the smallest side first, obviously opposite the smallest angle. So angle L is the smallest angle. The next angle, well, I'm going to choose the next smallest side, 5.5, which is opposite angle N. And then the largest angle, which is opposite the longest side. Okay? So I hope that all makes sense to you. I don't know if I can put it in any simpler way than what we already have. All right. Go ahead and do this one for me. This will be the last one from the examples here. Choose the smallest angle, then the next smallest angle, and then the largest angle. Okay. Again, if you did it correct, angle B should be the smallest angle opposite the shortest side. Angle D should be the next smallest angle opposite the next largest side, and then angle C should be the largest angle opposite the longest side. So again, angle B, angle D, and then angle C. Okay. Now I do want to look at, see if I've got an example here that, I think these are all pictures. Okay. So the next thing I want you to do is go ahead and pull out your textbook here. And your homework for tonight, let me go ahead and write that down on the board here. The homework for tonight is going to come from page 276 and 272, those two different pages there. From page 276, I would like you to do numbers 1 through 9. Okay, and I've got that pulled up here already, numbers 1 through 9. And then from page 272, I would like you to do numbers 22 to 30. Now, one thing about page 272, 22 to 30, make sure that you do those problems first in class, because you can't pull up that web page on that textbook page from the internet doesn't work for some reason. So, yeah, but it is in your textbook there. All right, now, looking at numbers 1 through 3, I actually want to work through numbers 1 and 2 with you, because the directions on this is a little bit different, and I'm going to say that nasty P word. You actually have to prove something here for these first two. So if you take a look at number 1, first of all, the question is, how can we prove angle 1 greater than angle 2? And I want to remind you of what we talked about earlier this year. What was the relationship we said that angle 3, angle 4, and angle 1 had? Well, if you remember, the sum of those two angles, 3 and 4, was equal to the exterior angle. We called these two the remote interior angles, 3 and 4. And angle 1 was the exterior angle. And so if you don't have your sheet of paper out, taking some notes down, as I said, we're going to work through these together. You might want to pause your computer and do that right now. Okay? So, with that being said, we already know that angle 1 is equal to angle 3 plus angle 4. Okay? And if you want to make a little note, this is the triangle exterior angle theorem. Okay, again, it's good to review that stuff, because I guarantee you'll probably see it again on your exam. Now, what else do we know about the picture? If you just look at the picture, what else do we know? And I would certainly hope that you would identify that angles 2 and 3 are equal, because they are vertical. So angle 2 is equal to angle 3, because vertical angles are congruent. Okay? Now from there, I could use substitution to go ahead and plug this angle 2 here into this equation. So I'll go ahead and show that. Angle 1, we therefore would know that angle 2 plus angle 4 by substitution. All right? And to finish this off, how then would we know that angle 1 is greater than angle 2? Well, if it takes angle 2 plus angle 4, we know that individually this angle 2 has to be smaller than angle 1. So angle 1 is greater than angle 2. Okay? All right? And that's actually called the comparison property of inequality, if you want to jot that down. This term we won't use very much. Comparison property of inequality. Okay, and so that's how you can prove for number 1 that angle 1 is greater than angle 2. Now I will say this, number 2 is a lot easier than angle 1, and angle 3 is a lot like angle 2, or number 3 is a lot like number 2. So what I'm going to do, I'm going to try to just erase the top part without the, well, I'm going to take the white off as well. Okay. All right, so to do number 2, I'm going to start the exact same way as number 1, but what I'm going to do for number 2, I'm going to get rid of some of this because it's really not needed. Okay? And so as we look up there, how are we going to prove angle 1 greater than angle 2? Well, I'm going to start the same way I did at number 1. I know that angle 1 is equal to angle 2 plus angle 4. Okay? Again, this is the triangle exterior angle theorem. All right. Now, if it takes angle 2 plus angle 4, like on the previous one, we would know that angle 1 would have to be greater than angle 2. Again, by the comparison property of inequality. Okay, all right, so that's what I need you guys to know. Just try to, how do you decipher through how one angle is greater than another? So I'm going to let you guys do number 3 on your own as part of your homework for tonight. I think you can think through that pretty well. Just the key right here, folks, is that the 2 lines are parallel. That's definitely going to be helpful in seeing as you work through that next problem. Now, I would like you to look down here at number 7, 8, and 9. And as you do those problems there, I want you to draw out the triangle ABC. I want you to label vertices, angle A, angle B, and angle C. And I want you to fill in the side lengths, 8, 5, and 7. And that way you can at least look at the picture and figure out which angle is going to be the smallest to which angle is going to be the largest. And so that is that's the format I'm going to give you on your chapter test, and I'll expect you to be able to do that. So draw the picture out, label the vertices, figure out which angle is. Pretty simple. All right. Now you notice, if I go back here, the homework from this page is going to have to do with inequalities, where you have something like this. I'll just write this down. Something like 3x minus 5 is greater than 2. Remember, you're going to go ahead and solve for x just like you would with an equal sign, but the only time it's going to be different is when you actually go to solve for x and you divide by a negative. Why is that? When you divide by a negative, you have to flip the inequality. Otherwise, the inequality doesn't mean it's not true anymore. Okay? So, like I said, I told you it was going to be a quick and easy lesson. That's all I have for tonight. And so, I wish you the best. I'll see you guys tomorrow.